A 0.15 gram sample of solid lead-2 nitrate is added to 125 milliliters of 0.1 molar sodium iodide solution. Assume no change in volume of the solution. The chemical reaction that takes place is represented by the following equation. PbNO32 plus 2NaI yields PbI2 plus 2NaNO3. Part A asks to list an observation that provides evidence of a chemical reaction between the two compounds. One example that shows evidence of a chemical reaction is the formation of a solid precipitate. A precipitate is a solid that is insoluble. A precipitate forms when the reactants are both insoluble. Insoluble means unable to ionize or break up into its separate ions. In the example of the problem, PbI2 is a solid because neither lead or iodine are soluble. Part B asks to calculate the number of moles of each reactant. We are given a balanced chemical equation, 0.15 grams of lead-2 nitrate, and 125 milliliters of 0.1 molar sodium iodide solution. Using the equation m times v equals moles, where m equals molarity and v equals volume in liters, we can calculate the number of moles in PbNO32 and in NaI. To find moles of NaI, we first convert 125 milliliters into liters. Then we multiply that volume by 0.1 molarity and find the answer of 0.0125 moles of NaI. To find the moles of PbNO32, we simply convert 0.15 grams into moles. We divide 0.15 grams of PbNO32 by the molar mass of 331.20 grams. We get the answer 0.000453 moles of PbNO32, or 4.53 times 10 to the negative fourth. Part C asks to identify the limiting reactant. To find the limiting reactant, we set up two stoichiometry problems, converting the moles of PbNO32 and NaI into grams of the solid product PbI2. To convert from moles to grams, we first divide by the molar ratio of the moles of the solid product of PbI2 to the moles of the solution that we are converting from. Next, we multiply by the molar mass of PbI2, which is 461.01 grams. We find that 0.000453 moles of PbNO32 produces 0.201 grams of PbI2, and 0.0125 moles of NaI produces 2.88 grams of PbI2. That means that PbNO32 is our limiting reactant since it produces less grams of PbI2. Part D asks to calculate the molar concentration of NO3- after the reaction is complete. The first step is to calculate the moles of nitrate in PbNO3. To find that, we multiply the 0.000453 moles of PbNO3 that we calculated from Part B. Then we multiply by the molar ratio of 2 moles of NO3 to 1 mole of PbNO32, because in every mole of PbNO32 there are 2 moles of nitrate. We find that there are 0.000906 moles of NO3, or 9.06 times 10 to the negative fourth. To find molarity, you divide moles by liters. We convert 125 milliliters into 0.125 liters by dividing by 1,000. Then we divide 0.000906 moles of nitrate by 0.125 liters and find the concentration of nitrate to be 0.00725, or 7.25 times 10 to the negative third. The last part of this question asks to circle the diagram that best represents the results after the mixture reacts. I chose the third solution because this solution contains sodium and nitrate as spectator ions, which means that neither sodium or nitrate react to form a solid participate, and because this solution contains excess iodine and a solid participate of PbI2.